Hello and welcome. I'm Jason from Periscope Data, and we are a company that provides business or tools for business analytics. We have recently been working on some fancy certifications to show, or we have been working on improving our security and getting a bunch of fancy certifications to show off, what we've done. And so I'm going to talk about how we achieve that with a small 10-person development team. So at Periscope Data, we take security very seriously. We want to protect all of our customers' data, and we want to use this sort of as a feature we can advertise and tell our customers about. Talking to some of our prospective customers, we found that SOC and HIPAA were the two most popular certifications that they asked for, and so we decided to investigate what it would take to get them. Most of the regulations are around processes, who can do what, do you have an employee handbook, do you have procedures for when employees join and leave, is all your data encrypted, are your keys rotated? Most of that we do fine. The place where we ran into trouble was in terms of separation of privileges. The biggest requirement that loomed over us was that no single person should be able to make changes to the production system. With a small 10-person dev team where everyone goes on call, that was somewhat problematic. So the old setup we had was Capistrano pushing Foreman applications to boxes just running on EC2. It worked when we were 5 engineers. It worked a little bit less well as we grew into 10 engineers. Capistrano is an old-school deployment tool where you SSHs from your laptop into production servers, can do git pulls, start, stop services, all pretty great. Except you have to run it on your laptop, we were running it on our laptops, which we can't do for Cap or for SOC. Also, having set boxes per service meant that any debugging we did was logging into the production box and seeing what was going wrong, trying to heal it, more of a pet than cattle, as mentioned earlier. So we wanted to move, not quite to serverless yet, we'll get there someday, but for now, just make our servers more disposable. Rather than trying to heal them, we can just get rid of them and get a fresh one that we think should work. Sorry. So as long as any production changes were reviewed by another person, then we were good to go. So we decided to use Git as our system of record here. So any commit to Git we use GitHub and GitHub protection branches, so any commit has to get approved, and we have some PR webhooks to check for things like GPG signed commits, make sure that whatever code is in master is safe to be deployed and is approved by our processes. So although Capistrano was pulling directly from Git and doing a build from there, which was all good, it was being run from dev laptops, which wasn't so good. So the first thing we tried was using sudo. So we have a jump box already to connect to the rest of our hosts. We figured I'll just put Capistrano on there. You can log in and deploy that way. It's actually super easy. Sudo is a great tool. I think it's a little bit unused. It can be super scary if you do it wrong and requires a pretty good mental model of Unix and Linux permissions to make sure that you don't accidentally let someone run sudo bash. But if you do it right, it's a great way to really quickly give permissions without exposing credentials. So this also leaves a lot of open questions. Who can edit this cap file? How do we keep it in source control? How do we edit it? So this was sort of a stopgap measure that we could use while we start working on something more scalable. So this sounds like a job for robots. Anything that involves repetitive tasks and is too dangerous for humans, we don't want to do. In particular, something to do with tests and code and deployment sounds like a job for a CI tool. So I asked all my friends what CI tools they used, how much they liked them, got a lot of mess. One of our engineers, Clay, recommended this new CI called Concourse from the folks at Pivotal Labs. And it seemed super awesome. We had already decided that we wanted to use Kubernetes for scheduling our containers in this new world. And like Kubernetes, Concourse is also entirely YAML config based. There's no servers to log into and buttons to type. You have a config file, you send it to the server, and it applies it. So this way, all our production changes are in Git and approved So all production changes that are going out have been approved by another person, and we, neatly fit into SOC requirements. So Concourse fundamentally is a pipeline runner. You have tasks and resources, which are connected in pipelines called jobs, or connected in jobs. This is sort of a rough example of ours. It's fuzzier than I wanted. But the general idea is you have resources, which are the small boxes, connected by tasks, which are the large boxes. Tasks are usually shell scripts or short Go programs, all wrapped in Docker containers. Same with the resources. Also very simple scripts or programs wrapped in a Docker container. So building your own tasks and resources is very easy. We made a simple Heroku resource that let us push our slug, let us build Heroku slugs and push them to production. Maybe 30 lines of shell or bash. So zooming in. So everything is triggered on git push. This is sort of the in progress modifier. So this whole thing flows left to right. We check versions here. We make sure that we do a final test pass, make sure that the merge didn't screw anything up, and then we start building a bunch of Docker images. So we have Periscope bin, which has all of our Go binaries, the Heroku slug, which is our Ruby web app, and then the tunneler, which is our Java processes that use JDBC to connect to all of our customers. We thought it'd be easiest to just put all the Go binaries in one Docker image, and then that way we can deploy it anywhere, and we don't need to manage so many images. You can see here the Concourse config is very simple. You have Clock Tower, which is a Git resource to find someplace else with just its name and some credentials to connect. And then you can get from it. We get from version, which is a semantic version. So just, version 1.0.3. We use this to name images. So it's easy when looking at Kubernetes to see, oh, this is the old image, this is the new image. We initially were using Git hashes, but it's hard to see, sequences there. So we get all of our resources, and then we build the Periscope bin image. This is a simple script that just calls go build and runs some tests. And then we do a put into the Periscope bin image, which calls Docker build and uploads it to our Amazon ECR registry where we store our images. We have a pretty simple environment. We are not a code democracy. You can use Go, CoffeeScript, Ruby, and a little bit of Java. So that makes all of this super easy. We don't need to worry about having proper environments because Go binaries are Go binaries, and they'll run anywhere. So what is... Oh, I missed one thing, sorry. So one last aspect of this is we want the configuration to be updated automatically. So when you check in new Concourse configs, we have a meta pipeline that just applies the pipeline you've checked in. So you can change the build process while still getting it approved. We don't need to have someone log into the Jenkins box and change some configs or something like that. It's all part of the same push process. So what is Kubernetes? Kubernetes is, as they say, or to quote their homepage, an open source system for automating, deploying, and scaling and management of containerized applications. So it just runs Docker on hosts for you. I really like the configuration-based aspect of it. So we use Heroku for our web app, and rather than moving to another pass like that would support the rest of our stack, I like the idea of having configuration in files rather than having to run commands to keep everything up to date. So the general idea for Kubernetes is you have containers which run in pods, which are managed by deployments, which watches them and makes sure they run, and they run on nodes, which is the abstraction of the physical hardware they're on. Services connect pods. So you have a pod that users want to talk to. You can create a service that will send traffic to it. And then all of our nodes are managed by Amazon autoscaling groups. Super simple user data file using Cloud init. When a new node comes up, it knows where the Kubernetes masters are. It registers itself, and tasks will just start scheduling on it. Oh, this is zoomed in a little bit. So in particular, pods have many containers on them that all share a network and disk space. We don't use this that much yet. Mostly we'll do things like have some logging agent run next to our container, or in a second container next to the rest of our services. So, configuring access. In addition to having signed production changes, we also need to ensure that developers can't just can't run their own images, can't just log into boxes and start doing whatever they like. But we need to retain the ability that when you're the on-call engineer or you're the engineer responsible for fixing a bug, you have the ability to do what you need to do. What we decided on was using role-based access, where each developer will have each developer can auth to two different roles. Normally, you act as a user, which has permissions to staging and some read-only permissions to production. And if you need to make changes, everyone has sort of a break glass admin certificate that they can use to connect to Cube as their own admin. We set up Slack alerts for this, so if someone uses it, we get notified. And that way, if someone changes something and we can investigate and say, like, hey, why are you pushing? And we can figure out. A last feature that we are using to help keep things secure is this idea of admissions controllers. So Kubernetes runs Docker images. You can set up webhooks to only allow certain Docker images. This way, even if someone wants to start some random Docker container, we can have a check that says, no, you can't run this in production, you can only run this in staging, or so on. So we talked a little bit about Git and our system of record. We've been using Git for a while. We've been using code reviews for a while. And when part of SOC is having, or part of the SOC requirements include a list of all changes that you've ever made, who signed off on them, who wrote them, which sounds exactly like Git, what Git is already tracking. So rather than doing over-the-shoulder code reviews, sometimes like we did, we now have a more formal code review process where you click the little box in GitHub when you're done, and then that will allow you to push to master. Fortuitously, GitHub released a bunch of changes around code reviews, including this approval bit, literally a day before we started looking into this. So that saved us a bunch of time. The last thing we had to lock down was AWS permissions. Again, developers had pretty broad permissions to look at resources, create new machines, and all that stuff. We still need this ability for access for on-call responsibilities, but we don't need it in general. So again, the solution there was to use AWS roles. AWS has a couple concepts in their permissions. Users, which are entities that have credentials, either passwords or access keys. Roles, which also have permissions, but don't have credentials. And machines can assume roles, Amazon services can assume roles, and users can also assume roles. And then policies is a set of permissions that you can grant to any of the above. A last option is you can put permissions on resources. AWS allows you to put permissions pretty much wherever you want. And if you put a permission, so I can have a permission on my user which says I can access a certain S3 bucket, or I can have permission on the S3 bucket which says it can be accessed by a certain user. We found that centralizing everything around policies, users, and roles was way easier for auditing and checking who can access what, so we moved everything there. Developers have a more restricted account. They can look around, they can see things, they can access a couple regions that are not our production regions, and if they need to do things like restart a Redshift cluster or look into a database or spin up a new instance, they can assume admin roles, which again logs to Slack, thanks to the magic of CloudTrail and Amazon API logging. So putting it all together, we have our beautiful Cube dashboard with all of our services. So if I want to push a new change, I write some code, commit it to Git, get make a pull request, get it approved, and then commit it. And I can create a snack while Concourse goes, runs some final tests, and starts building a bunch of Docker images and pushing them all to staging. We get a Slack alert when staging is ready, can go verify that our feature is working as intended if there's any manual testing we need to do. And then logging into the jump host using sudo again, we run a command to trigger a production deploy, which just talks to Concourse and tells Concourse to go the next step, which is kube control, edit deployment, and that's the new image that we have approved. And yeah, that's all I got. So questions, comments?
Do you use different Amazon accounts, or you said you're using different regions for production and dev?
Yeah. So right now, we're still trying to figure out exactly what we're doing there. But yeah, right now, everyone has their own accounts, and then we will just use different regions. So we use like US East 1 and West 2 as production, and then US West 1 is where people have dev RDSs and stuff like that. But we don't...
What happens if you have actually production in all of the regions?
Well, we'll get there. Yeah, so we don't do that much stuff. We don't have that much dev stuff on AWS. It's mostly staging. Most dev stuff is on people's laptops. The other stuff on AWS is for like analytics and stuff like that. And we'll probably end up moving to a separate account at some point because it'll be a lot easier.
And you talked about that you have a special container to SSH into Redshift. How do you cope with the problem that customers have to whitelist your IP address in order for you to be able to log in?
Yep.
Then you have a fleet and...
Yep. So this is a huge problem. Right now what we do is we have one box acting as a NAT gateway. So we also have a bunch of SSH tunnels and a couple legacy VPNs that we connect to. So one box manages all that. What we are moving to is using Amazon's new NAT gateways, which make it, it's the same idea, but now we have a NAT gateway that fronts all of the boxes, and then they can whitelist that IP rather than a random one.
Yeah, that's what we do, but you have this container that you use in order to SSH to the magic box?
Oh, no, sorry.
The magic box?
Yeah, so for developers, the jump host is just like Ubuntu image. For connecting to other customers, there is just a Docker image that runs the tunneler, which is our Java app. And so it's in a separate, we actually have two kube clusters. One of them, the tunneler cluster, connects to customer databases, is more locked down, so less people have access to it. And then I was talking more about our main cluster. So that one, all the workers are behind a NAT gateway. And then that one's a little complicated. There's so Kubernetes is just, you have a process called the kubelet, which when it starts up, it registers with the master, and then it will start scheduling things to run there. So you can have a pretty heterogeneous environment, and as long as they have kubelets that point at the same master, you can run whatever you want. So we have some boxes that are publicly accessible, some that aren't, that are behind this NAT gateway, in order to allow some people to SSH in for the SSH tunnels, but also we can connect out on a whitelisted IP.
You guys have you completely locked down SSH access to production instances, or is it still possible with this admin?
So the one thing that we're still trying to figure out is kube control exec. So Kubernetes allows you to use basically Docker exec on a container. And so what we've done now is, so Kube also has this API proxy, where all the calls you make are API calls, nicely namespaced, so we can just block out calls to exec. And other than that, there is a key to all we have like the Amazon key to log into all the boxes that we have in a safe upstairs for emergencies, but we don't use it for general purposes.
So you said that, so did I understand this correctly? You can SSH in, but you essentially just have read access, or do you not SSH in?
Oh, we just don't SSH in. Okay. Yeah, so a lot of the SOC is around policies. It's what is normal operating procedures. So when something goes wrong, you can do whatever you need to do to get things working, but someone has to be told about it, and it can't just be like part of your normal procedures.
So follow-up question to that. One issue that we had is that when dealing with it is that when you use the role-based permissions from AWS,
Yep.
then you can give your instances, you can assign policies to instances, right?
Yeah.
You can assign instances to roles and then policies to those roles.
Yep.
But if you have SSHN, then you're essentially in that role.
Exactly. And all of the services that run on that kube container can access that. What we're doing right now is using permission. So we use a mix of roles. So we used to use the roles a lot more before realizing that this means that all the Docker containers running on these instances can access things. So the controllers have a role which is different than the workers. And so the controllers have some configuration that they can decrypt that the workers can't. And then otherwise, we just pass credentials in using like Kubernetes secrets.
So different Docker containers get
Or-
different permissions somehow through that.
Well, I guess it's different EC2 machines. So our controllers are a certain set of EC2 machines, and then our nodes are a certain set of EC2 machines. And so permissions either are using access key and secret, or the role-based stuff is for the controller where users aren't logging in.
So with containers running within your pods,
Yes.
those containers can have different sets of permissions for EC2 services.
Oh, no. I don't think you... Oh, I mean, not if you use EC2 roles? No, I don't think so.
Right.
Yeah, I don't think you can
How do
use...
you guys do that?
Oh, we have credentials that are encrypted and stored and checked in.
And use Kubernetes
To distribute them. Yeah, secret distribution is one of the things that we've still been thinking a lot about. There's this HashiCorp tool called Vault that looks pretty awesome. The Kubernetes secrets we hoped would be more awesome, but it's pretty easy to pull secrets back out, and locking that down while still giving on-call engineers ability to do production things has been a little more difficult than we had liked. But there's a bunch of new permissioning coming to Kube that I think will help with that. But yeah, role-based, I don't know, I read something pretty recently about that was pretty down on EC2 roles, saying that just because you can go to that one URL from anywhere, it's really easy to steal credentials. So we've been starting to move away from that, unfortunately. It's a really cool idea. Cool. Thank you.